due to the charge distribution, the electrical fields line are created like this. Suppose if we have a charge distribution here, number of charges are there. So due to this charge distribution, the electrical fields lines are created in this way. Okay, and if you want to move this charge, this Q charge, from this point, this is the point A, to point B, because of the electrical fields line, so they apply some force, and that force is basically the Coulomb's force. The formula for the Coulomb's force is F. The force F is equals to Q into E, where Q is the charge, the trace charge, and E is the electrical field lines. Because of this charge distribution, the electrical fields line are created. So this force may be a negative force, may be a positive force. Now this depends upon the type of this depends upon in which direction we are moving. Either we are moving in opposite direction, then there will be an exerted force, the negative force that is applied. And if we are moving in the same direction as the electrical fields line is, then there will be there will be a positive force, not the negative force. So suppose this is a point charge at a point A, and as you know that from the Coulomb's law, F is equals to, this is the alternative form of the Coulomb's law, F is equals to Q into E, where Q is the charge, the trace charge that need to be moved from this point to this point, from point A to point B. Now see that this may be, suppose in electrical potential we have two voltage values. One is the positive, the other one is the 0 volt. So maybe at this point we have maximum voltage there. Okay, at point B the voltage will be 0. The voltage will be 0 because it's a difference from the positive voltage to the negative voltage or to the 0 voltage, because it is electrical potential or potential difference. It is a potential difference, maybe a maximum potential to the minimum potential. So on a trace charge Q, the force is applied due to the electrical field lines, trace charge. That depends upon how the trace charge is moving, because we need to move the trace charge in the opposite direction. So it means in opposite direction the force is applied, and that force has the value of negative F, because we are moving in opposite direction, not in the same direction. If you are going in the same direction, then it will be a positive force. Now we want to move a point charge from one point to another point. For that we always require an origin. So to understand the concept, when we are moving the point from one point to another point, there might be some distance covered, and to find out the distance we need to first define the origin, and the origin value, the origin has a basically 0 0 0 original vector, position vector. So first we need to define the origin. Suppose this one is the origin, and this origin the coordinates are 0 0 0, and this is on a point A, and this point has a coordinate x, y, and z. These are the coordinates. Now we need to move this point from point A to point B. So at point B the coordinates are, suppose this one is x1, y1, and z1. At point B it's all x2, y2, and the z2. Then it will be very easy to calculate the position vector and the distance vector. Very easy. We have already done this type of the calculations in the vector calculus. So to move a charge from point A to point B, there's some work done is basically performed. Because क्योंकि हम ये चार्ज जो है इस चार्ज को हम पॉइंट ए से पॉइंट बी तक लेके जा रहे हैं, क्योंकि इलेक्ट्रिकल फील्ड भी उसी डायरेक्शन में है, अपोजिट डायरेक्शन में है, तो हमें क्या है वर्क डन चाहिए टू मूव दिस पॉइंट ए, चार्ज जो है पॉइंट ए से पॉइंट बी तक लेके जाना होगा. तो फर्स्ट वी नीड टू फाइंड द वर्क डन. मीन्स हमें क्या करना होगा, इस पॉइंट से लेकर इस पॉइंट तक वर्क डन फाइंड करना होगा. So these are the position vector. RA and RB are the position vector. You can easily calculate these position vector by a formula that R is equals to x1 minus 0, okay, plus y1 minus 0 plus z1 minus 0. So from this formula you can easily calculate the values, the position vector values. So this will be in the x direction, this will be in a y direction, and this will be in a z direction. You can easily calculate the position vector. And your function is to find the distance vector, and distance vector can easily calculate it by making a subtraction from RB minus RA. You will get the position vector. So before finding the position vector, we need to find the work done performed to move a charge from point A to point B. ये आपका जो चार्ज है Q, इस चार्ज को हम इस पॉइंट से लेकर इस पॉइंट तक जब मूव करेंगे, so there is some work done is परफॉर्म होगा. तो हमें जब भी वर्क डन परफॉर्म करेंगे या जो भी वैल्यू साइन करेंगे, तो as you know that we are always taking as some differential length. हम क्या करते हैं, एक differential length कैलकुलेट करते हैं. If we know the differential length, then it will be easy to calculate the total length of that, a total distance of that path very easily. So, due to the charge distribution, the electrical field lines are created like this. Suppose if okay, so first we need to find this differential length dl. So this differential length dl is easily calculated, depends upon the coordinate system that we are using. Suppose the coordinate system is Cartesian coordinate system, then it is dx, dy, and dz. And if it is in the cylindrical coordinate system, then the equation will be rho, d rho, d phi, and d theta. And if it is in the cylindrical coordinate system, the spherical coordinate system, then the equation will be different. I think the formulas I have already given you in your first chapter regarding the differential length dl. So first we need to find this differential length, and if we know the differential length, we need to make an integration from this point A to point B to find out the total length or total path that covered by this charge move from point A to point B.